Okay, our last speaker, not the least, is Shayan Mohammadmoradi, unlocking the secrets of platelets, a new hope in battling deadly aortic conditions.
Testing. Okay, sure. Well, good afternoon, everyone. It's so great to be here and hearing about all the exciting research that's happening all over the campus. And as I was thinking about, okay, what I might have in common with all the research that's happening from my colleagues in math department, engineering department, or physics department, I thought probably it may be Albert Einstein. So Einstein was able to figure out many different puzzles that are happening around the universe. One thing that he did not be able to figure out, it was the deadly silent disease that was growing inside of him. And Einstein died of a condition called aortic aneurysms. So aortic aneurysm is basically a bulging, ballooning, or expansion of aorta. Aorta is your major blood vessel in the body. Think of it as more like a highway, a superhighway that gets the blood from the heart and takes it all the way all over your body. Like all the highways that are out there, there can be unexpected turns, unexpected expansions. And if the expansion starts to be too big and it gets too big, the aorta ruptures and bursts out. And usually all the blood starts to coming out of your body. And that's the deadly consequence of having an aortic aneurysm. What happened to Einstein? So one of the things that's interesting to know about aortic aneurysms is that although we have known about them for a very long time, we still do not have a drug for treating them. The only available options are complicated surgical procedures that do not guarantee the survival after the surgery. That's where my research comes in. In my research, I'm very excited and I'm very focused on understanding the underlying mechanisms of how aortic aneurysms form. And I've been able to figure out that there is this cool molecule called VAMP8. No, it's not another series of a vampire movie. Rather, it's a very interesting molecule that kind of acts as a gatekeeper. It controls the release of compounds from the cells in the body. And in terms of my studies, I have been able to see that when you genetically modify laboratory animals, you kind of switch off their VAMP8. What happens is that they dodge the bullet and they do not develop the aneurysm. So although it may be the tip of the iceberg, it has tremendous amount of therapeutic potential. And that's why in my research, I am extensively invested in understanding how the details of VAMP8 biology and how we can specifically target VAMP8 in order to only target them in the special cells that are residing in the aorta. The hope is that finally we can find a cure that future Einsteins will be able to conquer and defeat this hidden adversary, aortic aneurysms. And thank you very much.